Okay, in this video we're going to talk about division of complex numbers in their rectangular form. And you may have noticed if you just watched the last video on multiplication of complex numbers that when you multiply a complex number in rectangular form by its conjugate, here's what happens. You end up with a real number only. It's not a complex number anymore, which is useful. So let's show what happens, or a process for dividing complex numbers in their rectangular form. So this looks a little more complicated, but I think if you practice a couple times, you will get the process. So to divide a complex number we multiply the numerator and the denominator by the conjugate of the denominator. All right, so we are going to multiply both numerator and denominator by the conjugate of the denominator. So let's see that written down here in the question. So I have a division going on right here. You'll notice that the denominator is c plus dj. Now, the conjugate of c plus dj is c minus dj, and we are multiplying both numerator and denominator by the conjugate of the denominator, c minus dj. And look at what that is. C minus dj over c minus dj. So anything over itself is equal to 1. So we're not changing the value of this. We are changing the way it looks, however. And it will end up still as a complex number. And it'll still have the form a plus bj, right? So that's what we're aiming for. All right, so watch what happens. When you multiply the denominator by its conjugate, remember what happened? We got a real number. We just ended up with, if you look at the pattern, let's go back here. We ended up with c squared plus b squared, or bj squared, right? And therefore, this will be c squared, I'm sorry, I meant to say d, c squared plus d squared. So the denominator is c squared plus d squared. We'll eliminate those middle terms. And if you're wondering how this works, just do it again. You'll see the process. Now in the numerator, it's not going to happen because we're multiplying it by something different. We will still get a complex number, just like we did when we multiplied. It'll just be over some real number. Now, all of this will become a lot more clear when we take a look at a numerical example. So let's see. 4 plus 5j divided by 3 minus 7j. Well, first of all, we want to multiply both numerator and denominator by the conjugate of the denominator. So what will that be? To find a conjugate, you change the sign of the imaginary term. So this will be 3 plus 7j. And over here, 3 plus 7j. And I recommend brackets now because we're having binomials being multiplied by binomials. All right? Okay, let's go through. Straight FOIL all the time, okay? So 4 times 3, 12. 4 times 7j, which is 28j. You fix that, 8, 28j. Now 5j times 3, that's 15j. And 5j times 7j, which is 35j squared. All right, now let's do the denominator. I'm not going to use the c squared plus d squared just yet. I want you to see the middle terms canceling. Let's go through that process again. So 3 times 3, 9. 3 times 7j, which is 21j. Minus 7j times 3, which is minus 21j. See that? They're going to cancel. And minus 7j times 7j is minus 49j squared. All right, now back to the numerator. we have like terms right here. So 28j plus 15j, that's going to be, let's see, 38 and 5 is 43j. So this will be 12 plus 43j. And I can do another thing at this point. 35 is multiplied by -1. So this is minus 35. Okay. We also have like terms here. When we add them together, we get 0j. So that is just going to be 9, and minus 49 times -1, that's a plus 49. That's where we get the c squared plus d squared, right? Okay, one more thing. I just need to notice that I have like terms in the numerator right here. We have like terms down here. So let's do that addition. 12 subtract 35, we get minus 23 plus 43j, and that is over 49 plus 9, which is 58. Okay, now that doesn't quite look like anything we've seen before. However, 58 is a common denominator for each of those terms in the numerator. So this will be minus 23 over 58 plus 43j over 58. It's still in the form of a rectangular complex number. It's still the a plus bj. In this case, a is equal to minus 23 over 58. B is equal to 43 over 58. So sometimes we just change those to decimals. So minus 23 divided by 58, that'll get me minus 0.39. I'm going to go 3 decimal places, 397. And 43 divided by 58 is going to be 0.741. So this could be rewritten as minus 0.397 plus 0.741j. Okay, so that's what dividing or multiplying both numerator and denominator by the conjugate of the denominator does for us. It turns the denominator into a real number, still keeps the complex number in rectangular form, a plus bj, and gives us that new complex number being the quotient, which is the result of the division. Okay, thanks for watching. There'll be some practice posted. I highly recommend it.